Whenever we declare an inner class, the compiler automatically adds this implicit reference to the outer class object that caused the construction of the inner class object. So what we're saying here is before, whenever we were to create an object of the nested class, we had to pass an object of the outer class to make that work. And we had to have a reference variable inside the nested class to make sure we didn't have any compiler errors. What we're saying here is that's not necessary if we use an inner class. So let's say the name of our outer class is outer, then the implicit reference that we're given automatically is outer.this. So going back to our example, if the ArrayList iterator class is declared as an inner class instead of a nested class, so we would do that by not including the static keyword, and that means we can use myArrayList.this instead of the this reference variable. So they both would reference the same object from the myArrayList class. So we don't have to include the list reference variable anymore. It would be redundant. The inner class is really useful in a case where each inner class object is associated with exactly one instance of an outer class object. It sounds like what we're doing in this case, isn't it? So what we're saying here in this particular case, the inner class object can never exist without having that outer class object. So what we're saying here is we have this direct correlation between one object of the inner class and one object of the outer class. The inner class object cannot exist without the outer class object. So what we can do here is just whenever we create the inner class object, we're automatically given that exact object of the outer class. We don't have to specify anymore. It's not necessary. We're just given it automatically. So in this particular case, each object of the ArrayList iterator class would have an implicit reference to a myArrayList object. And what that means is we can actually simplify our code with the inner class. So let's take a look at that simplified code. Here's the first part of it, and the only difference here is this part right here where we actually create an object of the ArrayList iterator class. So notice that we're no longer passing the this reference anymore. We don't have to pass an object of the myArrayList class anymore because we're going to be given an implicit reference automatically. Here is the ArrayList iterator inner class. So we know it's an inner class because if we look at the top, we have private class up here. We don't have static anymore because remember, static would mean it's a nested class. Without static, it means it is an inner class. So we have an inner class here. And notice that any references to myArrayList are gone. We don't need it anymore because we're not passing an object of the myArrayList class anymore. It's given to us automatically. So the list reference variable is missing. Our constructor does not have that anymore. And notice that whenever we use references to the myArrayList class, we don't have to specify an object. So here we have our size method. We have the items current here, and we don't have to worry about including anything beforehand. Java does recognize everything from the myArrayList class because this is an inner class to the myArrayList class. So what we see here is we can actually replace the list.theItems with the items. Now we could do myArrayList.this.theItems, but that doesn't seem like an improvement. But because the way inner classes work, we don't have to do that. We can just say the items, and Java will know that it's coming from the object of the myArrayList class. So we're fine there. We also get a nice another improvement that involves the whole generic part of this. So since ArrayList iterator is tied to the myArrayList class, and we know that the myArrayList class is generic, then that means we don't have to explicitly state that the ArrayList iterator class is generic. We're just given that automatically. We don't have to specify it because ArrayList iterator is an inner class of the myArrayList class. And finally, what we find is we don't need that separate reference to myArrayList anymore. It's just gone. And what that means is we don't need a constructor in the inner class anymore. The only reason why we included that constructor was because we had to initialize the reference to myArrayList to the object that we passed in there. But since now they're connected, that constructor is no longer needed, and we're actually back to the style that we had in the first version of our code. Now, I do want to mention a little bit about the remove method. I didn't really explain that when we were looking at the code. We had the remove method given to us, public void remove. The way we can implement this is by calling the myArrayLists remove method. The one thing we have to be very careful with is I can't just say remove inside of that definition, because it would conflict with the ArrayList iterators remove method. So we have remove methods in both of these classes. So here we have to explicitly mention that we're talking about the remove method from the myArrayList class. So this is why we have to do myArrayList.this.remove in this particular case, because without it, then Java wouldn't know which remove we're talking about. Are we talking about myArrayList, or are we talking about ArrayList iterator? Now, it should also be mentioned that after this item is removed, the elements do have to shift. So that means for the current variable to be pointing to or viewing the same element, it also has to shift. Therefore, we have to decrease that value by 1. So that's why we have the minus minus current as the argument for this remove method. So what we find here is that inner classes are a syntactical convenience for Java programmers. We don't need to include them. They're not required in our code, but if we do include it, it allows us to write code in a style that's more natural, kind of like the first version of our code that was incorrect. So here what we're doing is we're allowing the compiler to write the extra code that we need to associate the inner class object with our outer class object.